This workshop will show you how to build sequences of instructions and how to use the microbit's built-in gesture inputs. In the first workshop, we saw how to display text, images and animations on the microbit LEDs. We also used the built-in microphone as a sound sensor. In those examples, the MrBit coding editor showed two control modules which worked in parallel with each other. Each contained just one instruction, but the parallel working allowed both instructions to be active simultaneously. This time, we shall create more than one instruction in a module and show how they get performed in a sequence. Let's see what we're aiming for. We start with a message when the button is pressed. Then there's an image. After tilting the microbit, we see an animation. Then another image. Then, after tilting the microbit the other way, we get another message. And finally, a little tune. We have now reached the end of the sequence and the program loops round to the beginning to start again. So that's the program. Here's how you can build it for yourself. We start with the first example from last time. We just want the hello message, so we delete the second button and module. This is the button for adding the second instruction. We choose a simple control which switches on the output straight away without waiting. It's going to show an image, so we link the Output tab to the LEDs. That's our first image, pointing left. This will show until the microbit is tilted to the left. To do this, we need a gesture input. This type of input uses the microbit's accelerometer to detect movement or orientation. Double-click on the box, and from the list we choose Tilted Left. Now the condition is tilted left. The third instruction will be an animation. We add another simple control, link outputs to the LEDs, select animation, and set about creating several frames. This repeat button saves the effort in duplicating squares. The dot in the middle is the target. The program calculates the time for one iteration. We'll increase that to show the animation several times. Notice how it loops back to the first instruction. Now back to design mode to build the sequence a bit more. Add instruction, make the image. This time it's an arrow pointing right. The image will show until the microbit is tilted to the right, so we need another gesture input, and choose Tilted Right. And the condition. The next instruction is for a message. We'll type bye which will take 3 seconds. So if we double the until time to 6 seconds, we can show bye-bye. Finally, for a bit of fun at the end, we'll add an instruction to play a little tune. For this, we choose a speaker from the Outputs menu. This will use the mini speaker on the back of the microbit. Now a bit of composing. Choose a note, make it short, make it high, and add some more. And speed it up a bit. We'll repeat it for 2 seconds. Now we are ready to test in control mode. Press the button, tilt to the left, tilt to the right. For our next example, we will use the program from the Mr. Bit tutorial on sequence control. Here we see the program running in the scene view. The sequence consists of just 3 instructions, each one displaying a letter. We can edit this in design mode. We shall begin by adding a light to each instruction. We will make the first instruction switch on the green light, the second will control the amber, and the third will control the red. We can see this working in run mode. Having successfully borrowed the program to control the lights, let's return to design mode and delete the microbit LEDs and its image. If we think about using the program to control traffic, you soon realize that real traffic lights require another instruction to show red and amber before returning to green. We are now well practiced to do this. Click the Add Instruction button, select Simple Control, and link the Outputs tab to the lights. We'll also set the time to 1 second. We can refine this with a button to make the green change. So instruction 1 needs editing to alter the until condition. There are 2 ways of selecting the instruction. We can use the arrows on the module, or we can point directly to the text in the program script. We'll delete the time condition and just select the button press. We could also decide that we should allow more time for pedestrians to cross the road while the red light is on. So point to the red light time and increase this to, say, 4 seconds. That's not realistic for crossing the road, but enough for our demonstration. Let's try this out with our microbit. Clearly, the coloured LEDs are not part of the microbit. We shall need to make some external connections. This is where the microbit sockets come in useful. And to help us make the connections in the right order, we shall check out the connections view from this button. We can see how the 3 colours are allocated to sockets 0, 1 and 2. With all the connections good, we are now ready to go in control mode. Our third example explores more uses of gesture inputs for the microbit. While this microbit is held in an upright position, the LEDs show an arrow pointing up. If we turn it to an inverted position, we see an up-pointing arrow again. Lastly, shaking the microbit shows an animation. Let's see how the control system and program script are constructed. To save time, we'll start with a partially built system which has the images and animation already prepared. There are 3 modules in parallel. Module 1 shows an up-pointing arrow. Module 2 shows a down-pointing one. And Module 3 shows an animation. We now need to create a gesture input for each. A double click on the block shows the available types of gesture. They are useful for detecting a position or movement. Face up is lying flat. Face down is the same, but upside down. Upright is standing vertically on edge. Inverted is the upside down version of this. Tilted left and tilted right we have used before. Then the remainder detect movement. We'll choose upright for our first instruction. Now the condition is upright. The image will show until there's a change from upright, so we will convert when to while. For the second module, we'll make a duplicate of this and edit the type to inverted. Then set the condition and while. For the third module, we'll choose shaken and make the animation last for 4 seconds. Now we have built the system, we can make it work on the microbit in control mode. Stand upright, and again, inverted, shaken. This last example helps us to see how the 3 modules, each with an instruction, are able to work in parallel with each other independently. Let's add some more modules to demonstrate this further. We'll need more space, so we'll remove the program guide and the text panel. We can still see the program script in this window. We'll also remove the shake instruction for now, but add some more position gesture inputs using the duplicate button. We'll set each input to a different type of gesture. Face up, face down, tilt left, and tilt right. And give each gesture a new image. We can see how it works in run mode. Notice that we can use any of the instructions we choose in any order. They are all active simultaneously. This is confirmed by the highlights which appear on all the instructions. This is in contrast to instructions in a sequence, as we saw in the first 2 examples. In those, we had just one module and used the Add Instruction button to build a sequence. Here's another way to make a sequence. We can merge all the modules from top to bottom into one like this. Highlight the modules, double-click on one, and select the Merge option. Notice how the program script has changed. Only one instruction is active at any one time, and they have to work in the preset order. The action to create a sequence can be reversed in design mode by another double-click on the module and select the Separate option. This might be useful if you want to change the order of the instructions. Just swap the modules around in the vertical order before merging. It is now time to make a summary of the tools we have used. We have seen how to use the Add Instruction button for building a sequence of instructions. For editing, we can select a particular instruction using these arrows on the module block or by pointing directly to the program text. We have used the Time tab condition for adjusting the show time for a message, animation, or image on the LEDs. Sometimes two inputs become connected to the When or Until tabs, and we need to delete one, like Time here. We have seen a range of gesture inputs that can be used for controlling outputs. We have used the built-in speaker on the microbit and composed a simple tune. We have connected external LEDs using the microbit sockets. The Connections view shows the allocation of sockets for correct connection. This workshop, together with the preceding one, have covered all the skills introduced in the first 6 Mr. Bit tutorials on the home page. You should now feel confident to try out the graded exercises for practice and reinforcement. In the next workshop, you will learn how to use counters and variables.